Hello everyone, this is the first video for differential equations, specifically on the chapter on Introduction to Differential Equations. Here, we are tasked to identify the variables for each of the given equation. That means we would like to determine what are the dependent variable, independent variable, and if there are parameters, we also need to identify them for each of the specific equation. So let's start with the first equation, the dy over dx, or the derivative of y with respect to x equal to cosine x. We can easily determine which is the dependent and dependent variable looking at our given expression here. Whatever variable that you can see here for our numerator would consider to be your dependent variable. So if I may, let me label here dependent variable and independent variable. For our first equation, our dependent variable is y and our independent variable is x. So as easy as that. Let's proceed to our second expression here. Okay, the second derivative of y with respect to x plus k squared y equal to 0. So again, as mentioned earlier, the variable that we could see for this expression that can be found in our numerator is your dependent variable, and what you can see at the bottom is actually for your independent variable. But take note that in our equation, there exists a certain variable k here, specifically k squared. This is what you can consider as your parameter. So we are going to label this parameter as our k. This k here could take other values, specifically constants, and there are also instances where we could use it for some cases. Okay, let's proceed to our third one. Okay, here we have no expression, or we don't have the expression of derivative of y in terms of, or with respect to x, but we can see here dx and dy in this manner. For situations like this, we could actually provide a different way of solving this, or expression where we could have two sets of dependent or independent variable. I'm talking about listing this first here. You have x squared plus y squared. You have dx, then minus 2xy, dy equal to 0. Let us try to divide all terms here by dx. Okay, if we are going to divide this by dx, of course that will be cancelled out. You will have your dx here, and of course 0 divided by dx on our right hand side will be equal to 0. Hence, this is equal to an expression x squared plus y squared minus 2xy, and the derivative of y with respect to x equal to 0. Now, without altering the rest, because there might be also additional explanation that could be brought here, but just by looking for this, by dividing all terms by dx, we can determine that our dependent variable would be the variable y, and our independent variable is the variable x. I mentioned earlier that there's also another case here, because if we are going to divide, let me use some space here at the bottom, using the given, then you have, I believe this was dx, 2xy dy is equal to 0. What if we're going to divide all terms by dy instead? Earlier we used dx, and this time we're going to use dy. That would mean dividing this by dy, in dy here, cancel that one. Of course, 0 divided by dy is 0. So we have an expression here, x squared plus y squared, the derivative of x with respect to y, minus 2xy equal to 0. For this case, we can see that x is now on the numerator, hence the dependent variable for this is x, and the independent variable is y. This is one of those cases where it could go in both directions because we are not given with the notation for derivative. Okay, take note of that. So let's proceed now for our number 4 here. Let me rewrite all of this 3 at the bottom because I don't have much space. So this is actually the partial derivative of v with respect to x in its second order, plus, of course, you will have this expression, the partial derivative of v, a second derivative of v, with respect to y equal to 0. We can see here the same presence of v and v in this case, but we have different variables here. This is the instance where we have one dependent variable, and that's actually v, but we have two independent variables, and the independent variables are x and y. Because v is, or we take the second order derivative of v with respect to both x's and y for this given differential equation. Okay, so pardon me again, I'm going to use some space here because I need to rewrite the remaining two. So we have here the cube of the second derivative of w with respect to x. We have here cube, this expression here, minus xy. You will have the first derivative of w with respect to x plus w equal to 0. So we can see here two sets of order of derivatives. We have here the second order, which is raised to the power of 3, and we have here the first order. We'll talk about order on a separate video as well. But obviously, our dependent variable here is actually this variable w. And our independent variable now is this variable here in the denominator, which is x. But take note, we have here a certain variable y. What does this represent? Similar to our k earlier on our second differential equation, it is what we call as a parameter. It's a parameter of y, which can take other values or specifically constants. And let's have the last one. The last given is x times the first order partial derivative of x with respect f rather with respect to x plus y times the first derivative of f with respect to y is equal to nf, the product of n and f. Okay, so following all the patterns earlier, the dependent variable here is this. You have your f. The independent variables, I mentioned variables because we have two variables here, x and y. And since we still have one more variable here, just simply call it as your parameter n. So this is how we determine the variables of our differential equation here. But before I end this video, I would like to insert one more topic about the type of differential equation, because there are only two. We call it the ordinary differential equation and the partial differential equation. Items 1, 2, 3, and 4 are what you consider as ordinary differential equation, and items 4 and 6 are what you can consider as partial differential equation. I'm just inserting that so that it would make this video more complete. Okay, so we'll have another video which will talk about types and order, and probably the concept of linearity as well. So for this, thank you very much for watching.